Okay, Unit 3, or Chapter 3, as the review guide says. So number 1, we have top 10 scores from a men's golf tournament, and we want to find the mean. So you could just add them all up and divide by the total. I'm going to go through and remind you how to do it in the calculator, because if there's a lot of data values, sometimes it's just easier to type it in, especially if you have to find more than like just the mean. So to type in data, you hit the stat button, which is underneath delete. You select that first option, which is edit, and then in L1 is where you're going to type in all of your data values. If you have values already typed into L1, you hit the up arrow so that L1 is highlighted, and then hit clear enter. That'll clear everything. Don't hit delete. If your L1 is gone, make sure you bring your calculator to me so I can bring it back. Then you're going to type in your data values. You do 65 enter, 66 enter, and so on for all of your 10 data values. And then once you have them all typed in, you're going to hit the stat button again. You're going to go over to the calc menu and select the first option, one var stats. Hit enter a few times until all that information pops up, and the first value in that list on your calculator, the x bar, is 67.7, which would mean D is the correct answer for number 1. All right, number 2. So we want to find the mean and the median. So again, we can just use our calculator. The calculator will tell us the median as well. So you go to edit, it will stat, and then edit, clear your values from before, clear enter, not delete, and then type in your data values. And then once you have them all typed in, you select stat, go over to the calc menu, one var stats, hit enter a few times, and then it says we're going to round to the nearest whole number too. So the x bar is 35.1, which would round to 35. Then if you hit the down arrow and scroll down, you'll find MED, that's the median, and that is 39. All right. Number 3, we've seen this question phrased like this a few times before. I'm essentially asking you to find the mean, the median, and the mode, but I'm asking you by using the definition of those. So we have our data, some quiz scores. So I'm just going to go ahead and type them into the calculator right away so I have them. And then letter A is asking to find the measure of central tendency that separates the data into 2 groups, such that each group consists of 50% of the scores above and 50% of the scores below that measure. So in other words, we have a data value, then there's 50% of our data on that side and 55% of our data on that side. So the value that is in the middle, that's the median. So if you do plug your data in and then go stat, calc, one var stats, scroll down, you'll find that the median is 15. For letter B, the measure of central tendency that represents the quiz score that occurs the most often, the one that occurs the most is the mode. The calculator doesn't explicitly tell you the mode. There is a way that you can reorder the numbers though. If you go to stat and then go down to option 2, sort A, and hit enter just once so it pops up on your screen, and then hit second stat and then select L1 and then hit enter again. Done should pop up. Then you go over to stat. If you go back to your list, so stat edit, all your values will be in order now, and so it'll be a little easier to see how many of each one you have. And you should see that I believe 15 occurs 3 times, and no other data values occur more than 3 times. That means our mode is 15. And then the measure of central tendency that represents the average of the 12 scores. Average is the mean. So if we go back to our one var stats, mean is 13. All right, number 4. Which measure of central tendency may not exist for all numeric data sets? Mean always exists. You can always find the average. Mid-range isn't a thing. Median, there's always going to be the middle. Remember, if there's 2 numbers that are in the middle, we just take the average. So there's always going to be a median. It's the mode, because remember, if there's more than 2 numbers that occur the most, so like 3 or 4, then we just say there's no mode. Or if they all only occur once, there's no mode. Calculate the mean, median, and mode for the following example. All right, so stat, edit, clear, enter, and type in our data values into L1. You still have to include the zeros, just so that your calculator knows how many data values there are. Then stat, calc, one var stats, And our x bar is our mean, which is 5.25. Scroll down to find the median, which is 5.5. And then the mode would be 0, because 0 occurs 3 times and nothing else occurs more than that. All right. Number 6, which measure of central tendency is not resistant to extreme values in a numeric data set? So not resistant, meaning that outliers would affect that value. Mean is the one that is affected by any extreme values, which is why when our data is skewed, we use the median, because that median is not affected by extreme values. Number 7, which measure of central tendency may have more than one value in a numeric data set? That is the mode. There's only going to be one mean. Again, mid-range isn't a thing that we've learned. There will only be one median, but a mode we can have up to 2 before we say there's no mode. So D is correct for 7. Number 8, if the graph of a distribution of data shows that the graph is skewed to the right, then if it's skewed to the right, that means the mean is larger than the median. So that'd be letter B for number 8. Okay, number 9, which measure of central tendency is more representative of the typical observation if the graph of the data is skewed to the left? So this is what I was saying before. When we have skewed data, no matter which way it's skewed, if it's skewed, we want to use the median, because median is not affected by extreme values. The mean would be affected by those values that are causing the data to be skewed. So the median would be the best option there, so letter C. Number 10, if the graph of a distribution of data shows that the graph is symmetric. So here when it's symmetric, then we can use the mean. The mean is the best. That means there's no extreme values that could mess it up too bad. So we'll do letter A. Mean is the better measure of central tendency. Compute the range. Range is the max minus the min. So we just need to find our maximum data value, which is 654, minus our minimum value, which is 120. And use 654 minus 120, you get 534, which would be B for number 11. Number 12, find the sample standard deviation for the following set of data. So remember there's 2 types of standard deviation. There's the sample standard deviation and the population standard deviation. Your calculator gives you both. Sample standard deviation is the capital SX in the calculator. If you have the little sigma x, that's the population standard deviation. So just make sure you're aware of the difference between those. So you would just type in your data, so stat, edit, clear what you have in L1, and then type in your data values. And then once you have them all typed in, you're going to go stat, over to calc, one var stats, and you're going to look for SX, which in this case is 6.39, which would round to 6.4. So B would be correct for number 12. 13, last year batting averages in a professional baseball averaged .256 with a high of .33 and a low of .224 with a minimum of 250 at-bats. Based on this information, which measure of variation could be calculated? So here all we know is the mean, and then we know the maximum and the minimum. So here, standard deviation, we don't know how to calculate it with just those 3 things, so we can't do that. Range we could do because we have max minus min, so we'll keep that one option open. Percentile, we need to know the specific data values in order to calculate percentile, and variance is just standard deviation squared, so we can't do that either. So range would be the only thing that we could calculate with the information that we're given, because we know the minimum and the maximum. All right, number 14. When results from a scholastic assessment test are sent to test takers, the percentiles associated with their scores are also given. Suppose a test taker scored at the 95th percentile for their verbal grade and the 49th percentile for their quantitative grade. Interpret these results. So percentile tells you the percentage of values less than the given data value, whatever we're looking at. So if they scored in the 95th percentile for their verbal grade, that means they did better than 95% of the people. 95% of the other test takers did worse than them. So let's look at our choices here. Student performed better than 5%. That would not be it. It's 95. Whatever the percentile is, that's the percentage they did better than. So it can't be A or B. So that leads C or D. Both have the 95% better for the verbal. So then if we look at our second one, the quantitative, 49th percentile means they did better than 49%, which would be option C, not D. All right, 15, cholesterol levels. Find the percentile that corresponds with a cholesterol level of 195. So I believe these are already in order for us, which is awesome. So we need to find 195, just right there. To calculate the percentile, we need to count the number of data values that are strictly less than the one we're looking at. So we're not going to include 95. We're only going to count the values that are less than 95. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That's our numerator, divided by the total number of data values, which is 30. There's 30 adults. Then we're going to multiply that by 100. So we would do in your calculator 14 divided by 30, hit enter, times 100. That gives you 46.66666 repeating. Percentiles can only be whole numbers, so you need to round to the nearest whole number. So 46.66 repeating would round to 47, so it'd be the 47th percentile. So D is correct for number 15. Okay, number 16. Given the following 5-number summary, find the, interquartile range. So 5-number summary, meaning this is the minimum, 37 is Q1, 50 is the median, 66 is Q3, and 94 is the max. So 5-number summary, remember, are the 5 numbers that we use for box plots. So the interquartile range is Q3 minus Q1. So we would just do 66 minus 37. So you got to make sure that you're reading the directions carefully. If you didn't read carefully and see that this was the 5-number summary, you might just think these are 5 data values and plug them into your calculator, and that would give you the wrong answer. So make sure that you're reading carefully and you know what exactly the data is that you're being given. So C, 29, would be the correct answer for 16. All right, here now we're given some data, 19 test scores, and we want to find the 5-number summary. So your calculator will give you the 5-number summary. You just have to type in the data. So you would go stat, edit, clear your L1, clear enter, type in all of your data. Type them all in. Once you have them all typed in, you go stat, calc, one of our stats, hit enter a few times, and then you got to scroll down. The 5-number summary is towards the bottom. And so we get that the minimum is 52. The first quartile, Q1 or lower quartile, is 72. The median is 76. Q3 or the third quartile or upper quartile is 84. And the maximum is 96. Also, just keep in mind another thing to remember, that median can also be called Q2 sometimes. It means the same thing. So just be aware if you ever see Q2, they're just talking about the median. Okay, number 18, we're going to draw a box plot now. So in order to draw a box plot, we need to know the 5-number summary. So we can type in our data values into our calculator again. So stat, edit, hit the up arrow, clear enter to clear your L1. Type in all of your data values. Make sure you're being careful that with how you're typing them in, you're not making any typos. If you make any mistakes, then your calculator is just going to give you the wrong answer. You won't really know that they're wrong unless you go back and double check your work. And then once you have them all typed in, you're going to hit the stat button again. Go over to the calc menu and select one of our stats. Scroll down to see your 5-number summary. And then I'm going to write down my 5-number summary first, and then I'll draw my box plot just so I have my numbers. So my minimum is 31. Q1 is 56. The median is 72. Q3 is 83, and the max is 99. And I believe that was another typo on the answer key. Q3 should be 83, not 84. And then once we have our 5-number summary, we need to draw a number line. We have to evenly label it. So our minimum is 31, so I'll just start at 30. We have to go up to 99 or 100. So 40, 50, 60, oh, that's going to be too big. 50, 60, 70, 80, 90, and I'll scooch 100 over. Make sure that your increments are evenly spaced out as best as you can do. Then my minimum gets a point at 31. My maximum gets a point at 99. Q1 gets a vertical line, median gets a vertical line, and Q3 gets a vertical line. Draw your box, and then connect your box to your whiskers. Alright, 19. Interpreting a box plot of a set of data, we note that the median is to the left of the center of the box and the right line is longer than the left. So let's go ahead and sketch that out. So median's to the left and right line is longer. So when it's skewed, it's whatever side has the longest whisker. That's the way it's skewed. So since the right is longer, that means it's skewed right. So A would be the correct answer for 19. And our last one, number 20, we're going to find some outliers. So we first need to know the IQR to do outliers. So you do have to type in your data into L1 so you can get your Q1 and Q3. So you go Stat, Edit, clear your L1, clear Enter, type in your data values. And remember, when we're finding the upper and lower fences, these are just telling us the boundaries to help us look for outliers. The numbers that we get for the fences are not outliers themselves. It's just giving us the bounds that we can use when we look at our data. And once you have all of your data values typed in, then you go Stat, Calc, var stats, and scroll down until you find your Q3 and Q1. So Q3 is 46.5. I don't know why I did it backwards. Q1 is 19. Okay, so upper fence, you take your upper quartile, which is Q3, plus 1.5 times the IQR. Let's go ahead and calculate the IQR over here. That's Q3 minus Q1. So 46.5 minus 19 gives us 27.5. So we'd have 46.5 plus 1.5 times 27.5. Which gives us 87.75 as our upper fence. Then we can look at our data and see, are any of our values larger than 87.75? There aren't any. 56 is the largest, which is still within that bound, so we're good there. Then we do the lower fence. Should be our lower quartile minus 1.5 times the IQR. So that'd be 19 minus 1.5 times 27.5, which equals negative 22.25. And none of our values are less than the lower fence. None of them are negative, so this means there are no outliers. All right, and that is it for Unit 3.